Welcome back to our Python learning series. In our previous videos so far, we've covered many concepts. We started with the basics, understanding what Python is, why it's so popular, and how to install it on different operating systems. Next, we explored various integrated development environments, or IDEs, and discussed which ones are best suited for Python development. We then moved on to the core building blocks of Python, working with variables, understanding different data types, and defining functions to make our code more modular and reusable. After that, we learned how to control the flow of our programs using conditional statements like if-else and loops like for and while to repeat actions efficiently. We also explored how Python handles different types of numbers, from whole numbers, integers, to decimal values or floats. Then, we dived into working with text data, covering string methods, slicing, formatting, and manipulation techniques that help us handle textual information effectively. In our last session, we introduced Python's built-in data structures. We learned about lists for ordered collections, tuples for immutable sequences, and sets for unique elements. Now we move on to our next topic, dictionaries. Dictionaries are one of the most powerful and flexible data structures in Python. They allow us to store and retrieve data using key-value pairs, making them ideal for handling structured information efficiently. Let's dive into Python dictionaries with a fun example. Imagine we have a team of superheroes, each with their own unique power. We can store this information in a dictionary where each superhero's name acts as the key and their special ability is the value. Here, we create a dictionary called Superhero Powers. Inside it, we define 4 superheroes. Spider-Man, whose power is wall crawling. Iron Man, equipped with an advanced suit. Thor, wielding the power of thunder. And Doctor Strange, who masters the art of magic. With this simple structure, we can quickly access or modify superhero abilities using Python's dictionary operations. Now let's print our dictionary to see the full list of superheroes and their powers. Now let's see how we can access a specific superhero's power. By using the key Thor, we retrieve his special ability from the dictionary. Python will return Thunder God. Next, we use the len trolley function to find out how many superheroes are in our dictionary. Since we've added 4 heroes, the output will be 4. This makes dictionaries a powerful way to store and manage data efficiently. Python also allows us to create dictionaries using the dict method. Let's take a fun example from the world of video games. Here, we create a dictionary called Video Game Heroes using the dict function. We define a legendary character, name, Mario, power, super jump, world, mushroom kingdom. Once we print this dictionary, we'll see all the key value pairs neatly displayed. This method works just like the curly braces syntax, but can be more readable in some cases. Now, let's explore how we can work with individual pieces of data in our dictionary. First, we use the get method to access the value of a specific key. In this case, we want to know Mario's power. By calling videogameheroes.get of power, Python returns superjump, which is Mario's special ability. Next, let's see how we can get a list of all the keys in our dictionary. We use the keys method to do this, which will return all the keys, in this case, name, power, and world. This gives us a quick way to see all the categories of information stored in our dictionary. Now, let's see how we can add new items to a dictionary. We have a dictionary called Superhero Abilities, where each superhero is paired with their unique power, like Spider-Man with wall crawling, Iron Man with his advanced suit, Thor with the power of thunder. But what if we want to add another superhero? It's super simple. By using dictionary name of key equals value, we can add a new entry. Here, we add Doctor Strange with the power of magic mastery to our dictionary. But what if a superhero evolves and gains a new ability? Instead of adding a new entry, we can update an existing superhero's power using the update. For example, Iron Man started with an advanced suit, but later he upgraded to a nanotech suit. With superhero abilities.update, we replace his old ability with the new one. This method allows us to keep our dictionary dynamic and up to date, just like superheroes constantly upgrading their gear. Sometimes we need to remove a superhero from our dictionary. Let's say Spider-Man decides to take a break from superhero duties. We can remove him from our dictionary using the pop method. Now, when we print the dictionary, Spider-Man is gone, leaving only the remaining heroes. Dictionaries store data in key-value pairs, and Python lets us loop through them easily. First, we use values to loop through just the superhero abilities. This prints out all the powers without showing the hero names. Next, we use keys method to loop through only the superhero names, listing each hero one by one. Finally, we use items method to loop through both the names and their abilities, displaying them together in a formatted way, just like a superhero database. In Python, a nested dictionary allows us to store multiple dictionaries inside another dictionary, making it perfect for organizing complex data. For example, consider the game of PUBG. Here, different weapons have unique stats like damage, ammo type, and category, and we can structure this data using a nested dictionary. Here, we create a dictionary called PUBG Weapons, which contains 3 weapon categories. The assault rifle category includes the M416, which deals 41 damage and uses 5.56mm ammo. The sniper rifle category features the AWM, a powerful weapon with 105 damage, using 300 magnum ammo. Lastly, the SMG category has the UMP45, which delivers 39 damage and uses 45 ACP ammo. Now, we loop through this dictionary, first printing the weapon category, formatted properly for readability. Then, we go one level deeper and print each weapon's name, damage, and ammo type, ensuring all details are displayed clearly. To keep things structured, we also add a separator, making it look like a well-organized in-game weapon stats menu. This approach helps us efficiently manage weapon data in a way that's both dynamic and easy to access. Think of a dictionary like the tokens given at shopping malls for storing your belongings. The token number, which represents the key, helps you quickly retrieve your bag, which represents the value. Just as each token number is unique and linked to a specific bag, dictionary keys are unique and mapped to corresponding values. In Python, dictionaries have some key characteristics. First, keys must be unique. Each key can only appear once in a dictionary. Keys are usually strings or numbers, but they can be any immutable data type. Now, the values in a dictionary can be anything. You can store strings, numbers, lists, or even other dictionaries as values. This flexibility allows you to work with a variety of data. One of the key strengths of dictionaries is that they are mutable, meaning you can dynamically alter them. You can add new entries, remove existing ones, or even modify values associated with a key, all on the fly. Dictionaries are particularly useful when you need fast data retrieval. For example, if you're managing user profiles, settings, or configurations, dictionaries allow you to quickly look up data using a custom key, making them an excellent choice for these types of applications. In the next video, we'll explore object-oriented programming in Python, focusing on classes and objects. We'll see how classes act as blueprints for creating objects and how objects bring data and functionality together in a structured way. Understanding these concepts will help you write more efficient, reusable, and scalable code. Stay tuned and thanks for watching.